In this session, I'm going to explain about the ozonolysis of alkenes. This topic is there in both the 11th standard of CBSE as well as in the 12th standard of CBSE. In 12th standard, it is there in aldehydes, ketones, carboxylic chapter under preparations of aldehydes and ketones. How is this done? What is ozonolysis? Usually, an alkene can be taken as a starting material, and when it is subjected to ozonolysis, it gives a ozone oil, which then further can be reacted with zinc powder and water to give aldehyde or ketone. It depends on the starting material that you are doing. So, firstly, in the starting material, alkene, we can do the substituents as R1, R2, R3, and R4. These R groups can be uh, hydrogen, it can be an alkyl group, it can be even an aryl group. Okay. So when it comes to alkyl, we are going to check with simple alkyls, methyls, and ethyl. So what's going to be the product? Okay, so we are not only changing R1, we are doing the change for R2, R3, and R4 as well. So for individual substitutions, what are the products that we are going to get on when an alkene is subjected to ozonolysis? So initially, we'll consider R1 and R2 as hydrogen, or we can do with all the R as hydrogen. So in that case, hydrogen, 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 hydrogen. So where your R1, R2, R3, and R4 are hydrogen. So this, when subjected to ozonolysis, gives an ozonoid of this particular format with the attached hydrogen as such. So this is what is generally known as ozonoid. So this on further reaction with Zn and water makes the compound break some bonds. For example, these two oxygen bonds will be broken and this oxygen will be attached with Zn and they will be getting a byproduct, that is Zn, so that we keep separate. Apart from that, this bond breaks and that makes this into a double bond as well as this one. So the product is going to be like this, double bond O, and the other side of the carbon is also going to be the same. So we are getting methanol, that is also known as formaldehyde. So when we take hydrogen as a substituent in the main carbons, okay, we are getting aldehydes. Like when we substitute methyl in all the places, so that's our second type. So methyl here, methyl here, methyl, and methyl. So now the name of the compound is also a thing that we need to see and learn. So now this is a butene and it's 2-butene. So obviously we have this methyl branches that also to be named. So hence the modification will be like 2, 3 dimethyl but 2-ene. So now this is your starting material and we are doing this ozonolysis using ozone. Ozone is a poison, it's a dense gas. So which when reacts with this alkene such a ozonoid will be obtained. So, which on further reaction with Zn and water breaks this bond and breaks this bond and makes this one into a double bond and this one into a double bond. So, the final product will be CH3 to that carbon, same CH3 is attached. Double bond O plus the second carbon with the two methyl substituents and a double bond O, and the bond is also to be mentioned is ZNO. So now the name of this compound is propanone. We are getting two propanones, which is also known as acetone. So now, so when we take all the R1, R2, R3, R4 as methyl group, we are getting ketone. So from this we can understand that if a nitrogen is substituted, we are likely to get an aldehyde, and if a methyl group is substituted in the place of R1, R2, R3 and 4, we are getting a ketone. So if only one of the substituents is methyl and the other one is hydrogen, that will also lead to the aldehyde. So that case also will see methyl here, hydrogen here, methyl here and hydrogen here. So now the name of this compound is butene, it's 2-butene. So which is on ozonolysis will be giving a product like this. So with one CH3 and one hydrogen and one CH3 and one hydrogen, which on further reaction with Zn and water will give a compound with a double bond O and hydrogen over here. Similarly, in the other side, carbon with a double bond and hydrogen. So we are getting a byproduct also, that is ZnO. So this is ethanol, which is also known as acetaldehyde. So now these are the varieties that we are getting. So in case if you want both aldehyde and ketone in the same reaction, we can go ahead with this particular ketone. Okay, whereas my R1, R2 are methyl and my R3 is methyl and the R4 is hydrogen. So now this substitution on ozonolysis will be giving you the ozonoid of this format. So where you have two methyl over this side and one methyl and one hydrogen over there, which on further reaction with Zn and water breaks the bond over here. So you are getting a double bond over here. The final product will be like C double bond O CH3. This is a ketone, which is propanone ketone. Then the other product with the C double bond of H, which is an aldehyde, which is ethanol. So this is an aldehyde, and you have this byproduct ZnO as well. Okay, so like this, you can get an aldehyde mixture or ketone mixture or an aldehyde ketone mixture just by changing the substitutions R1, R2, R3. So a long chain compound, even with multiple double bonds, can also undergo ozonolysis, where this ozonoid will be formed in the particular double bond positions, which breaks the compound. So usually this question, this topic will be asked in your competitive exams, like what is the reactant if a product is given. Likewise, if a product is given, what is the reactant? So these two questions we need to work it out, and to work out that, this particular format will be easy to understand this type of reactions. Thank you.